Hello YouTubers. This video is a second one about programming SIMATIC TP070 with TP Designer. In this video I will cover some subjects about communication with S7200 series PLC. Don't forget to subscribe to the channel and like the video. Let's get started. As you know, TP070 was designed as a low-end unit for the SIMATIC S7200. This touch panel is equipped with one interface for use with MPI. So no special cables are required to connect it to the PLC. Here is a pinout of DB9 2 male connectors. I have used cable AWG28, but you can use AWG26 or AWG24 for longer distances. Start your Step 7 Micro Win program. From the Tools menu, start TP Designer. First we need to configure communication. In TP Designer's Setup menu, select Communications. Here you can see three tabs. First one holds settings to configure communication between PC and TP. Second one holds settings for communication TP to S7200 PLC, and third one is language. As I mentioned, TP070 is equipped with one interface for use with MPI. For communication PC to TP you can select one of two serial ports. Modern PCs are lack of serial port, so it can be replaced by USB serial converter. When you get your USB to serial converter installed, make sure that its port is either number 1 either number 2. Baud rate supported by the TP is from 1200 to 38400. If your PLC has only one serial port, I do strongly recommend to keep the baud rate same as PLC. Switch to the tab TP to S7200. Here you need to save settings for the communication TP to PLC. TP address. Find any free address on your MPI network, and assign it here. S7200 address is the address of your PLC on the MPI network. You can find it from your Micro Win communications. Protocol will be MPI, it is static. I have already mentioned that TP070 is equipped with one interface for use with MPI. Baud rate. It can be found from your PGPC interface. Keep in mind that there are only two supported baud rates, 9600 or 19200. So your PLC should operate on one of these. If the communication settings will not meet what is set in the PLC, then there will be no data exchange between PLC and TP. Let's find the address of the PLC. You can do that from Communications, located in the Micro Win. The address of the PLC is 2. CPU is 224, release is 01.22. Let's check for baud rate, used by PLC in the PC-PG interface. I am using S7 PC adapter USB. Transmission rate is 19200. Let's switch back to the TP Designer. I am going to use my previous project. Open up Communication Properties to see the settings. As you can see, TP address is 10, PLC address is 2, baud rate is 19200. All the communication stuff is set. For the test purpose, I have wrote a simple program with a timer. Let's create some tags. Here I have 3 Boolean tags that are used in the PLC program. Tag T101 will represent timer value. VW10 is the set point for timer. By configuring tag, select PLC type as S7200, as we are going to operate with the tags of the PLC. Acquisition cycles. Here you can select read continuously, if your tag is sensitive, or you can select cyclic read write. Please keep in mind, that one cycle is 200 milliseconds. The number you put in the input field is not milliseconds, but count of cycles. Let's say, if you will write down 5, then your tag will be updated on 200 multiplied by 5 will be 1 second interval. Next, select your data type and memory area. You can also assign some functions to your tags on value change event. Switch to your screen. Drop down text field on the screen, and change its text to VW10. It is a memory area of the timer setpoint in the data block. Drop down the input on the screen, and assign timer's setpoint to it. Here we will change the setpoint of the timer. Drop down output on your screen. Output will represent current value of timer. That type of field prevents users to input data into it. Add 2 buttons to increment or decrement timer setpoint by 1. Select button for increment. Switch to the Functions tab. Select on button up event and add function decrease value. Assign tag VW10, it is a setpoint of our timer. Repeat same steps with another button, but this time, select function increase value. Add one more state button, select type switch, and display text. We will start or stop timer by the help of this switch. Assign tag M10 to it. If the switch is on, tag M10 will be true. If the switch is off, then tag M10 is false. You can assign additional functions, but they are not in use in this example. Add another state button. Its purpose, to restart timer when the job is finished. Choose type as push button. Select event on button up, and assign function reset bit. Assign tag M12. Select event on button down, select function set bit, and assign same tag M12. It means that, when the button pressed, M12 is true, when the button released, M12 is false. Add 3 more outputs. They will represent the state of tags M10, M11, and M12. Add 3 text fields with the texts corresponding to the tags names. Make screen as startup screen, by clicking right button of the mouse on it, and selecting set as startup screen option. Or you can set it via properties. A small red circle shows up at the right bottom corner of the screen name, indicating that it is startup screen. Compile and save your project. Download it to the panel for test. Now let's test our project. Initially, setpoint for timer is 200, because it is set like that in the data block of the PLC. So it is 20 seconds. Let's decrease it to something like 5 seconds. Click on Start, and timer should start to count. As you can see, the state of M10 has changed to true. Timer finished the job and tag M11 went to true. Click the restart button, tag M12 changed to true, counter started over. Release the button, tag M12 changed to false. Let's try to change setpoint by the help of the increment and decrement buttons. Our application works well. That was a demo on objects text field, input, output, and state button. Also detailed explanation on the communications PC TP, and TP PLC. Don't forget to like the video and subscribe to the channel. Thank you for watching and happy coding.